The object of this experiment is to determine the phase angle and ratio error of a current transformer by Petch Elliot method. So shown over here is the circuit diagram that will be required to perform the experiment, and on the right side shows the phasor diagram. So before performing the experiment, it is suggested that you go through the details of what this experiment is about, and you go through the manual that had been provided to you related to this experiment. So shown here is the experimental setup, the equipment that will be required in order to perform the experiment. So we'll require a CT testing kit as shown here. Then we have a non-inductive loading resistance, and we have a multimeter in place of galvanometer. So in the circuit diagram you will observe galvanometer while we have available multimeter. And then there is the CT which is to be tested. Then there is a standard CT, a variable load, and a one-phase transformer. So if we look into the CT testing kit, then we'll observe that there are certain uh, control keys on the panel as well as some control rheostats. So we'll look into what they are. So if you look into this rheostat, so this rheostat is used to control the phase angle, while this one is used to control the ratio error. Then here is a knob that controls the galvanometer sensitivity, and then we have this display for knowing the current that flows through the circuit. This is the knife selector switch, which will be used to select uh, the secondary current of the equipment under test. Then we have the terminals where the connections shall be performed. So on these terminals we can see written as ML standard load, X load, then we have MLX, then we have V galvanometer. And this shows the standard CT which is being used in this experiment, the top view of it, and the connections are shown. Then we have the front view. This is the left side view, and this is the right side view of the standard CT. And this is the top view of the single phase transformer that is being employed, and the ratings are shown on the bottom right side. Then there is a non-inductive loading resistance employed, and if we try to correlate the equipments which are being used in the experiment with the circuit diagram, then this particular thing is the CT, the CT under test, and this is the standard CT. This is in place of auto transformer we have a single phase transformer, and then for the CT testing kit we have corresponding to this part of the circuit, and this is the non-inductive loading resistance. Then we have primary current which is provided by the loads given here. Then in place of galvanometer we'll be using multimeter. So using this circuit diagram we now perform the connections. So connections have been done here, and here shows the experiment that is being performed. So if you go through the manual you will understand that the procedure, how we will be following the steps from that manual. And on the right bottom side we will be populating the table corresponding to the readings that we are going to observe. So the leftmost column will correspond to the switches that are being controlled, switches it will be written on the left side of this table. Then we have the second column as current in amperes, then range switch, then we have ratio switch, and then we have ratio dial in terms of percentage, then we have phase angle switch, the phase angle dial, and the burden. So we observe the first set of reading where switch S1 was on, and we have current of 18, range switch at 5, which means that that the current will be multiplied by 5. The ratio switch is negative. The ratio dial percentage is 0.09. The phase angle switch is leading. The phase angle dial is 15 minutes and the burden is 2.5 VA. And we're taking the second set of reading. Here is the second set of reading where switch S2 is turned on while S1 was turned off, and the following things were observed. Third set of reading where S1 and S2 switches are on. Now following this is the fourth set of reading. So now S1 and S2 are kept off while S3 is turned on, and the corresponding observations are noted down. Now we'll switch towards the burden of 5 VA. The first set of reading corresponding to 5 VA where S1 is turned on and the corresponding reading is noted. Then we turn on switch S1 and S2 only, and we'll observe what the reading is observed. For this we have the following reading. Now S1, S2 both are turned on. and we'll finally obtain the reading when S1, S2 both have been turned on. And finally the set of reading when S1 and S2 are turned off while S3 is turned on. So the final reading is shown here. So now you'll have to make a report comprising of the following questions. The first is, what is the difference between a CT and PT? Second, what do you understand by the term burden of current transformer? Third is, mention the factor on which the phase angle and ratio error depends. And fourth is to plot the graph phase angle error and percentage ratio error of the CT against percentage full load current and discuss them.